Okay, so far we've been looking on Replit at some C# code. It's made a auto-generated name for me there, interesting one. But mainly we've been looking at the sequence of commands, the syntax, like the fact they all end in semicolons, and some data types like integers and strings. I'm going to take a little bit of this out. Just pare it back so it doesn't get a bit too cluttered. And we're going to look at the second type of flow control. So flow control means how your program flows from one instruction to the next. And right now it's just flowing from one instruction to the next in sequence. But there are other options, and one of those is called a conditional branch. And conditional branches come in a few different forms, but by far the most common is something called an if statement. Now you'll notice it turns blue when I type in if. It recognizes it as a keyword built into the C# language. So an if statement always has the word if, followed by a condition, and that condition is always inside round brackets, parentheses. And the thing that goes inside the round brackets must be a boolean value, so it must result in either a true or a false. And you can literally just type in true or false there. It's not much use to do so though, I'll show you why. When we say if true, that's your condition, and then we need something that happens when the condition is true, and that's called a consequent. So for example, we could write a piece of text that only occurs when the condition is true. So it could greet us if we are a particular person, but currently I've set the condition to just be true in all cases. It's hard coded and it's what's called a literal Boolean value. So that's not much use for an if statement because if statements always check if the condition is true, and if you just literally write the word true in there, then it's always going to run the consequent. Let's run it and enter name. Sounds okay. It runs the consequent, but of course if you put in somebody else's name, it still runs the consequent at all times because it says true here. If I was to change that to false, then the opposite would happen. It does give you a warning because it knows that something's not quite right. But if I type in anything at all here, because the if statement checks the condition, which is always false, it means the consequent never runs. Because remember, the consequent runs when the condition is true. Because we set it to false, it never runs. So putting true or false in here, the only real use for it is for debugging purposes. You can take a line of code out by putting it inside an if false. Another thing worth mentioning is the consequent, there's only ever one thing in the consequent. And in this case, I've got a single statement saying console.writeline. If you want to do more than one thing as a consequent, then you have to combine it into one thing by putting it inside more curly brackets. So I could have, for example, two console.writelines in there. I'll just put that back to true for now, just to debug it. So now when I run, I forgot a semicolon. Hide and seek champion, semicolon. Okay, so put in any name, and it does say both of those things that I put in as a consequent. If you were to accidentally forget that and put in the bracket early, even if you leave the indentation in, by the way, indentation doesn't actually affect the flow. Or if you leave the brackets out, that's the most annoying example because then it looks like these two are part of the if statement because of the indent, but in fact, only the first one's part of the if statement. So if I make that false, it shouldn't run the consequent, so it doesn't run this line, but it will run this line because that's not actually part of the if statement, despite the fact that it looks like it is. That is the correct level of indentation where it should be. So there we go. It doesn't say hi because it's false, but it does say how are you because that's not part of the if statement. Okay, so if it's not much use to put in true or false in there, what can we put in? Well, we could put in a Boolean variable. Let's just declare one. So I'm going to create a Boolean variable which is going to decide whether we're logged into an admin account. And we can use that instead of our literal true or false. We can put in a local variable. Let's not leave us all cluttered up. Okay, so we create a boolean, we then check the boolean. But the thing is, we don't know the value of that boolean, do we? If you don't put in a value, if you don't give it assign it an initial value, it will always have the default. And just to prove to you what that default is, oh, what have I done wrong? Use of unassigned local. Oh, in fact, it won't even let us do it locally. It would let us do it if it wasn't a local variable. For example, if I put it up here, and of course, remember, things have to be static if they appear outside here, because the main function is static. It can only see static things. Okay, so because it's no longer local, it doesn't recognize that it's unassigned, and it will let us run it. There we go. It will always have its default value false. So that kind of gives it away. What is your name? Doesn't matter. Anything at all. It doesn't say hi Dave because the admin account has its default value, which is false. So that's equivalent to saying if false. Okay, I'm going to move that back in down here though. And then it will go back to giving us an error. Yep, unassigned. Let's assign it something then. We can assign it a true or false value, which is kind of a long road for a shortcut. We're just taking that true value and assigning it to a variable and then using the variable. So why would we even bother doing that? Well, you can assign a value based on the outcome of some kind of calculation or comparison. For example, we could say our admin account is equal to the outcome of a comparison, which I'll put in brackets. And that comparison is our name Dave? Has the player typed in Dave as their name? And if they have, that comparison will be true. And if they haven't, that comparison will be false. And whatever you get as a result, we're assigning that true or false into here. So now we don't know in advance whether it's going to have a true or false value. It depends what the player chooses. So if they do choose to type in Dave, with a capital D by the way, it is case sensitive. But if they do, it will say hi to me. Oops, double clicked it there. So type in the name Bob, for instance. Bob is not equal to Dave, so that would give us false. Admin account is false. So the if statement does not run the consequent. But if I do type in Dave, that is the two are equal. The variable will contain Dave, and that is equal to the literal string Dave. So that is true. Admin account becomes true, and it does run the consequent. And that's extended quite a ways in when you go into more advanced things, but that's the basic idea. It is pretty unusual to see it done this way, to be honest. Usually a boolean is set as a result of an if statement or return value from some function or something like that. That's much more common than a direct storage of a comparison. And the reason for that is because we could get rid of this variable entirely and simply put that comparison in as our condition. That's much more convenient, much more readable, clearer, easier to debug, many advantages. So you almost never see it done the other way. If there's some kind of comparison you can make, it's very common to actually put that in directly as the condition. That should work exactly the same. There we go. Okay, so you can put in a single consequent, or you can put in a code block, actually in brackets, as a consequent. Excuse me. Now, what I'm going to do next is show you an alternative. So we could put in what happens if the name is not Dave. Well, we put two equal signs in to compare. Up here we had one equal sign, which means assign a new value. Double equals means compare. But we don't want to make the exact same comparison again. We've done that already. We want to make the opposite comparison. And if you want to see if something is not the same, that's the symbol for it. Exclamation mark equals. It means not, that exclamation mark. So that's not equal to. We're asking if the name is not equal to Dave. And if it's not equal to Dave, we can say something else. So you'll get two different lines of text depending on whether you type in the word Dave or not. Okay, that sounds good, and quite often that is fine. Certainly is fine in this case, but sometimes that leads to incorrect flow. For example, if the condition itself changes as a result of the consequent. For example, let's say if you log in as Dave, that is your admin account. So we're going to change name to admin. Doesn't sound too unreasonable. But now when it gets to this thing here, it says if your name is not Dave, we're going to do something else. And of course, by now, we've changed our name, so it no longer is Dave. So that consequent is now true as well, and it's going to run both. Oops, that's not what we wanted. So this is where the alternative comes in. So if I replace that with the word else. Now the word else must occur after a consequent for an if statement. So it always has this pattern: if, brackets consequent, brackets condition, beg your pardon, followed by a consequent, then immediately followed by the word else. You cannot put anything in between here or it will muck up the flow. And that else is also followed by a consequent or code block, which runs when this if condition is not true. So because it's based on the same condition, it can only ever run one consequent, that one or this one. And whenever it completes that consequent, it jumps straight to the end of the else statement and onto the next line of code. So now if I run this and put in a different name, it doesn't say hi Dave. But if I type in Dave, it doesn't say you're not my father. So it chooses one path or the other. That's why it's called a branch. So it branches one way or the other, but never does both. Okay, so some languages have other things called else ifs, so you can check more than one condition. C# doesn't have that, but you can just tag another if statement on to the end of an else, and it's essentially the same thing. So I'm not going to stress you with that right now. There is another condition you can have, and that's called a switch. Let's take all this out and try a switch. Most languages do have a switch as well as an else, as well as an if. So if we switch based on whatever your name is, what that's saying essentially is we're going to compare your name to a bunch of different possible outcomes called cases. So in the case that your name is Dave, we're going to say one particular line of code. And in the case that we put something else in, we're going to say a different line of code. Now, there's some odd syntax in here that you see hardly anywhere else. So you switch based on one variable, and then you have different cases which check the variable against certain literals. But then you also have a semicolon, a colon, not a semicolon. The only other place you'll likely to see that is in a label, and this is actually quite similar to a label because it jumps straight here if that matches. Then it runs a certain piece of code if it matches. If it doesn't match, it checks the next case and keeps on going. You can put in a default case, which it will run when it doesn't match any of the cases. And the other thing is, this is going to give us an error, I'm sure. Well, several errors. Cannot fall through from one case to another. Unreachable code detected. So these are all because at the end of each case, you need to put in what's called a break. And the break will actually jump to the end of the switch. Or well, it actually jumps to the end of whichever block it's in. And it just so happens that in a switch, the block ends here. So each one of these needs a break. In some languages like C++, you don't have to put that in, and you can manipulate that to do some unusual things, but it's very easy to mess up with that, so C# doesn't let you do it at all. What you can do though, is you could put in multiple cases that fall through to the same amount of code. That's what fall through means. So we've got a lowercase d and a capital D. Both of those will fall through to the same control block. So it should now respond to both of those properly. So that's a switch in a nutshell. It's a bit more situational, not as useful, not as likely to be useful as the if statement, but it certainly does have its uses, so you should be aware of its existence. Next thing we're going to look at is randomization, because in game development, there's usually always some element of randomness in games, whether it's to do with the AI or the outcome of some attack or something like that. So how do we do random numbers? The thing is about random numbers in computers, they almost don't exist. When you put in something that will generate a random number, it's called an RNG, by the way, a random number generator. It's not actually generating truly random numbers. It's generating what's called pseudo-random, which is a complicated amount of maths, which I don't claim to understand. But it does result in a sequence of numbers which, to a casual observer like you and me, have all the appearance of being random. Anyway, let's get on with this. We make an RNG. Now it's based on the random object class. So it's like declaring an integer. You use the word random instead of integer, but you still give it a name. Oops. So random RNG, and I don't know if it's going to recognize that because I don't have a using in. No, it seems to have done it. Well, I do have a using. Okay, so the RNG now exists, but it's never used. That's what that warning is saying. Before we use it though, well, in fact, let me show you what happens if we try and use it. So we can say RNG dot. Now the dot operator is called a reference operator. It is used to refer to things inside the object on the left. So what's inside the RNG? Well, there's a function called next inside the random object. And the next command has three different possibilities. You can just do next random number. And it'll give you a completely random integer. Now, integers are 32-bit numbers, so you'll get a random number somewhere between 0 and about 4 billion. Not always useful, so you can instead put in a number in here like 100. What that will do is it will give you a random number less than that. So somewhere from 0 to 99. It does not include 100. And the final option is you can put in two numbers, and it will give you a number that is equal to 10 or more, but less than 20. So that range is between 10 and 19. However, if we try and run that, use of unassigned local variable. This has happened before. What does unassigned mean? It means you haven't given it a value. What value can you give to an RNG? Well, it's not just a variable, it's an object. So we need to assign an object to here. We need to create a new object. So there's a word called new, which does that. So you tell it what kind of object you're going to create a new instance of. I'm going to create a new random object because that is what we need. We've said that it's going to be a random, so we're creating a new random. So constructing a new random object uses something called a constructor. Every class has a constructor. And that constructor is code. It's a method, a function. So it needs brackets, although quite often they are empty. Not always, but quite often. And what that's going to do is seed the random number generator. I did tell you it's all about maths. So you need to have a number to start with. That's called the seed number. You may have seen the seed number in games like XCOM, Minecraft, Civilization. Essentially, it's a number that starts off a sequence of apparently random numbers. So if you use the same seed, you get the same sequence. Usually, the seed comes then from the time on the clock in milliseconds, because that's the one thing that's pretty much guaranteed to be different every time you run this code. Okay, so that is how you construct and seed a random number generator and use it to actually generate numbers, but you can't just leave that on its own. It might compile, I'm not sure. It does. It might just, it does compile, but it won't do anything, or at least not anything useful. It's going to generate a number, but then do nothing with it. So let's plug it into an if statement. We'll make a random number between 0 and 2. So it's going to give us either a 0 or a 1. And that's like flipping a coin then. So a 0 could be a heads, and a 1 could be a tails. So if a random number generator flips a coin, 0 or 1, and happens to get a 0, then we're going to consider that or pretend that is a heads. So let's say heads. Else, which remember means that we didn't get a 0, we must have got a 1. You can say console.writeLine tails. I might take out the name stuff just because it's going to slow us down a bit. So it's just going to say get ready and then seed the random number generator and flip a coin. What's never used here? Private field main class. Oh yeah, this one here. Because I took that code out, it's not used anymore. Okay, tails you lose. Tails you lose. Oh, it seems to be getting tails a lot. That's the thing about RNGs though. They are random, so you don't expect them to give you runs of the same thing, but sometimes they do. That's just how randomness works. Okay, but some people might do it like this. So you have one RNG check, and if it's a 0, you win, and if it's a 1, you lose, which might sound like it makes sense, but the problem there is it's doing two separate random number generations. So you could end up with two different numbers, and you could do both of these or none of them. I did one that time. I did both that time. I did neither that time. That was quite a handy demonstration. So you really have to use else in there for RNG. Okay, now the next thing is type conversion. So let's say instead of flipping a coin, we want to do a sort of, you know those things you get at county fair where there's a jar of marbles and you have to guess how many marbles are in the jar. Let's do something like that. So we're going to get the computer to give us a number of marbles. And that's going to be an integer number, a whole number. How many marbles will there be? Well, let's choose a number between 1 and 100. So 100 is less than 101. So there'll be between 1 and 100 marbles. And the computer is going to make a guess, which is also going to be a guess somewhere between 1 and 100. Now we're going to let the player make a guess as well. We're not doing that just yet, because we need to prompt him and say, guess the number of marbles. So the player guess, we're going to assign it a value, which it gets from console.readLine, which we used that before, didn't we? I'm pretty sure we did. So it's going to read a line of text and store that as an integer in player guess, or at least that's what we're wanting to do, but we cannot do it. Cannot implicitly convert type string to integer. Console.readLine, it does read a line of text from the keyboard, and although you could type in 90, you could also type in your name, and that would be a string of text. So readLine always gives you a string, but player guess is an integer, and that is a type mismatch. It can't do it. So what it tries to do is say, well, maybe we can convert that for you. That's called implicitly converting, but unfortunately it can't. So that's why you get the error. It can't implicitly convert, so what we have to do as programmers is explicitly do it. Tell the computer how to convert. And there is another class called the convert class, also in system, just like console. And the convert class has a bunch of methods in it, like this one, convert to integer 32. And you can pass in various types of data and it will try to turn them into numbers. Now if I type in, there's just warnings because things are not used yet, don't worry about that. Here's our actual main output. If I type in a number, fine. If I type in a letter, you get an exception, a runtime error, a very different type of error. Something that only happens, or can only happen, after you've compiled and ran the game. So there's actually three types of errors. Some of them are compiler errors, which you get when you click run. There are runtime errors, which happen during the program running, probably later on. And there's logic errors, which means the program runs, but it just doesn't do the right thing. So in this case, this is a runtime error. And that usually results in what's called an exception, an exceptional situation, something that shouldn't have happened. What happened was it tried to convert a string to a number, but it couldn't do it because what you typed in wasn't a number. I typed in A. There are ways to resolve that in code. I'll leave that for another time though. Let's just presume that the player is always going to type in a number. Not stable code then, but baby steps. Okay, so now we've got the number of marbles. The computer's made a guess. The player has made a guess. Let's see who is closest. Well, let's say we have an integer which tells us how different the computer's guess was from the actual number of marbles. How different was it? Well, take the computer's guess and subtract the actual number of marbles. That is the difference between them. Let's do the same for the player. See the autocomplete there, by the way. Start typing in a few letters. You can move up and down between suggested answers and press enter or tab and it will fill it in. Most IDEs do that. Right, so now we can say console.writeLine. It's always good to just output stuff so that the player can see what's going on. What did the computer guess? Copy and paste. And what was the actual number of marbles? Well, we'll display that on the screen as well using concatenation. But who actually won? Well, we could compare how far the computer was from the guess with how far the player's guess was. So that's using greater than. That symbol there means greater than. That means less than. Oops, hang on. That there means less than. You can also combine it with equals. You can say less than or equal. You can say greater than or equal. You can say exactly equal. And of course, you can say not equal. Those are your main comparison operators. Anyway, if the computer difference was higher than the player difference, we could assume that means the computer's guess was out by more than our guess was out. So therefore, the player wins. And if that's not the case, then the computer wins. Let's see how that goes. Guess number of marbles, let's say 50. Computer guessed 51, actual marbles 35. I was closer. Okay, sounds good so far. Let's try 2. Computer guessed 23. Actual marbles 68. I was closer? That's not right, is it? So what's happened there is we were out by 21. Sorry, no, that's the difference between me and the computer. We were out by 66. The computer was out by 45, and yet it thought we won. And the reason for that is because of this comparison here. We're comparing the computer difference with the player difference by saying greater than, but actually negative numbers, which is what we've got here. We had 2 minus 68 and 23 minus 68. They were both negative numbers. And when you go into negative, the smaller negative number is actually greater than the larger negative number. So what we're going to do is make sure there are no negative numbers. And one way to do that is to use another library called the math library. It has a function in it called absolute, ABS for short. The absolute value of a number is just exactly the same as the number was before, but it gets rid of any minus sign. So like if you had 5 or a minus 5, the absolute value of those both would be 5. Absolute of minus 20 is 20. Absolute of 14 is still 14. So all it does is get rid of a minus sign if there is one. So because they're now both definitely positive, we can compare the differences, and it should work this time. Oh, unexpected symbol, curly bracket. Yeah, it didn't expect to see this curly bracket because I haven't closed this one. That one's closed. That one's closed. But somehow I've forgotten to put in or accidentally deleted a parenthesis. One character and it fixed 3 errors. That's welcome to programming. Okay, so how many marbles? Let's guess 2. Computer guessed 17. Oh, I was closer that time. That's luck for you. This time, computer guessed 4. Actual marbles 56. So the computer was closer, and it's recognized that properly this time. So that is the math library. There's lots of stuff in there like sine and cosine and all that sort of stuff. But the most basic one there is absolute. I'm nearly finished, but one thing I want to look at is a thing called refactoring. Now, refactoring means taking some code and making it better, but doing the same thing. Now, what do we mean by better? Does it mean it runs faster, uses less memory, easier to read, easier to debug? Well, the answer is yes, it can be any of those things. So any improvement at all, but still doing the same job. For example, this math.absolute here, we've got 2 of them in this comparison. It makes it a little bit hard to read. What we could do instead is we could do the absolute while computing the difference, like that instead. And we could do the absolute for the other one while computing the other difference as well. And that will result in the same outcome. It works. But it makes a bit more logical sense, at least in my head anyway. That's refactoring. You can, even doing things like this, so that it's using brackets or not using brackets, technically that's refactoring, and it's not to meet the standards of whatever organization you're working for. So that's what refactoring means. Changing the code, ends up doing the same thing, but in a better way somehow. Okay, now one last thing, definitely last thing this time, is combination logic. So we've got logical comparisons like greater than, less than, etc. Let me put in a different game. So this is a game called odds and evens, I think it's called. So you choose to put 1 or 2 fingers out on your hand. Not gingers, fingers. So we're going to convert to a 32-bit integer whatever the player types in, which we're going to trust the player to type 1 or 2. So we should get a 1 or a 2 there. And our RNG is already initialized, so we're going to take the number of fingers, and the computer is going to do the same thing. So he's going to use a number between either 1 or 2. So 1 is the minimum. 3 is the excluded maximum, so that will be somewhere between 1 and 2, that will give us. So either the player is going to choose 1 or 2, the computer is going to choose 1 or 2, and it should get between 2 and 4 as an outcome. So we need to know whether it's even or odd. So we're going to declare a variable that will store the result. We'll initialize it with the initial value of false. So we're going to assume it's not true. This is quite common in programming, to assume something's false until it's proven true. So we assume it's false. But if the number of fingers is divisible by 2, then it is even. How do we divide by 2 and get a remainder though? We can't just do divide by 2. That will give us the answer. But there's a command that will divide by 2 and give us the remainder. It's called the modulus command, and that's a % symbol. So if you divide by 2 you get a remainder, compare that remainder to 0. So if there's no remainder when dividing by 2, then you've got a number which is even. So that consequent, you could put it inside curly brackets. I do recommend that in most cases, especially for beginners. But just for demonstration purposes, I'm going to show you that you can actually even put it on the same line. Commonly only done if it's a single small piece of code that's result, but you can do it. Some people consider that a sin, but it definitely does compile okay. Okay, so we've worked out whether it is odd or even, but we now need to ask the player whether he thinks it's odd or even, because we need to find out if the player guesses correctly. So ask the player and then get his choice, which is going to be a string, because we're getting it from readline. You have to type in odd or even, so that's going to be a string. Save it in a variable there called choice, and if you've chosen odd while the number is not even, then you got it right. So you chose odd and it is odd, so say yes, it is odd. But if it doesn't meet both of those parameters, oh sorry, I did gloss over that, didn't I? That double ampersand, it means combine the two. So check if the choice is odd and at the same time also that variable is false. So this whole condition will only come back true if both of these comparisons come back true. If it is even, or if you've chosen even, then it will ignore that and go to the else part. So either you haven't chosen odd, or you've got it wrong. The next thing we need to do is then check, well, what if you chose even and got it right? If your choice is even, and it is even, then again, you've got it right. Oh, hang on, I spelled that wrong. But there is a third possibility, which is what if you haven't got it right? Now we don't need to do 4 checks. You could do if you want, I suppose it wouldn't hurt. You could check, is choice odd and it is even? Is choice even and it is odd? But actually we don't need to do any of those conditions, because if you got it right with an odd selection, it would do this one first. If you got it right with an even selection, it would do this one first. So it would only ever get here if you didn't get it right. So it's a bit like the default case. If none of these conditions evaluate true, you haven't won the game, so you must have lost the game. That's basically how that works. Let's hope I've not made any typos. Okay, choose 1 or 2 fingers, press 1. Odd or even? It is odd. Okay, nice. I guess it would have been nicer to say the actual number of fingers, but never mind. 2, even. Okay, the computer must have chosen 2 as well. Just to prove, I'm going to keep going until I get it wrong. Yeah, there we go. The computer must have chosen 1 finger. 2 plus 1 is 3, that's odd. And I got it wrong. Okay, so I think that's enough for one video. We've looked at if statements, conditions, operators, even the modulus operator. So that's plenty for now. I'll come back with some more in a bit.